In less than 6 days, the modern world could go dark. Not weeks, not months, 6 days. And scientists just put a number on it, a number they've started calling the crash clock. What it says is worse than anything Hollywood has dared to show you. Every text message, every GPS ping, every weather alert, every bank transaction verified by satellite time signals. It all runs through one thin shell of space called low Earth orbit. 200 to 1,000 miles above your head, tens of thousands of satellites are flying at 17,500 miles per hour. Faster than a bullet, faster than you can process. And right now, they are too close together. Much, much too close. Here's a stat that should stop you cold. Across all of low Earth orbit, 2 satellites pass within 1 kilometer of each other once every 22 seconds. Inside SpaceX's Starlink shell specifically, every 11 minutes. A single Starlink satellite has to dodge a collision 41 times a year on its own, autonomously, because there are too many near misses for humans to handle. In just 6 months of last year, the Starlink fleet performed 145,000 collision avoidance maneuvers. That's 272 dodges every single day. In December of 2025, a team of astrophysicists from Princeton, the University of British Columbia, and the University of Regina published a paper that quietly detonated across the space community. It's called an orbital house of cards, and buried inside it was a brand new metric, the crash clock. Crash stands for collision realization and significant harm, and what it measures is simple and horrifying. If every satellite avoidance system on Earth went offline for any reason at all, how long until we get a catastrophic collision? Back in 2018, the answer was about 164 days. Comfortable, forgettable. Today, the peer-reviewed answer is 5.5 days. The original draft said 2.8. Let that sink in. In 7 years, our margin for error in space shrank by 97%. Now the researchers are begging people not to misread this. The clock is not a countdown. Nobody is saying the internet dies next Tuesday. What they are saying is this: the system only holds together as long as every operator, every algorithm, every piece of software makes a perfect decision every single day. Lose control for just 24 hours. One day and there's a 30% chance of a major orbital collision. A 1 in 4 chance it involves Starlink. One day. That's not a margin. That's a tightrope. So what could actually knock out control for a full day? Not a hack, not a war. The sun, specifically, a coronal mass ejection, a billion-ton cloud of charged plasma, traveling at 1,000,000 miles per hour, slamming into Earth's magnetic field. When this happens, 2 things break simultaneously. 1, radio signals distort. GPS bends. Satellites lose contact with the ground. 2, and this is the one almost nobody talks about, the upper atmosphere eats up and expands upward into space. Suddenly, satellites that were flying through near vacuum are punching through thickened air. Drag spikes. Orbits warp. Spacecraft drift unpredictably in every direction at once. This isn't theoretical. February 2022, a moderate solar storm destroyed up to 40 brand new Starlink satellites before they could even reach their operational altitude. $50 million gone in hours. May 2024, the Gannon Storm. More than half of every operational satellite in low Earth orbit had to burn emergency fuel just to stay in place. Thousands of spacecraft all maneuvering at once, creating secondary near misses from the maneuvers themselves. Think about that. The fix was almost the disaster, and all of that, the 40 destroyed satellites. The Gannon fuel burn panic was nothing compared to what scientists are really afraid of. The Carrington Event, 1859, the most powerful geomagnetic storm in recorded history. Telegraph lines caught fire. Auroras were seen near the equator. If that happened today, the lead author of the crash clock paper says, positional uncertainty in orbit would become so extreme that ordering an avoidance maneuver could mathematically make the collision more likely. The safest move might be to do nothing. And hope. Now we get to the real monster in the room. Kessler Syndrome. Proposed by 2 NASA scientists back in 1978. The idea is terrifyingly simple. If space gets crowded enough, 1 collision becomes 2. 2 becomes 10. 10 becomes a cloud of thousands of shrapnel fragments, each one a hypersonic bullet, each capable of triggering its own collision. It's a chain reaction. And unlike chemistry, it doesn't burn out. Because at orbital altitudes, there's nowhere to slow the fragments down. They just keep going, keep hitting, keep multiplying, until entire orbital bands become unflyable. Not for years, for generations. Hollywood shows you Kessler Syndrome is a 2-hour disaster. Satellites explode all at once. Survivors scramble. Credits roll. The real scientists say, not even close. The buildup of an impenetrable debris shell takes decades. That sounds like good news. It isn't, because the seed event, the first unavoidable collision that locks the cascade in that event, is what's only days away in a control blackout. The dominoes fall slowly. But once the first one tips, there is no putting it back. Let's talk about what's already up there. Right now, this second, there are an estimated 130 million pieces of debris orbiting Earth. 40,000 of them are bigger than your fist. Over 1 million are between 1 and 10 centimeters. And the rest? Millions upon millions of millimeter-sized fragments. Paint flakes, bolts, metal shards. And at orbital speed, a 1 millimeter piece of metal has the kinetic energy of a bullet fired from a rifle. It can pierce spacecraft shielding, depressurize habitat modules, kill astronauts. In November 2025, China's Shenzhou 20 spacecraft had its window cracked by a micro-debris strike. The return had to be delayed. That wasn't fiction. That happened in April 2026. India's space agency released their official situational awareness report for last year. The numbers are brutal. 328 launch attempts in 2025, the most in human history. 4,651 new objects added to orbit. In a single year, over 160,000 close approach alerts for ISRO satellites alone. And that's just one country. Meanwhile, 82 planned maneuvers had to be redrawn mid-flight because the new path the satellite was about to take would have created a second collision risk. We are now routing around our own routing, the orbital equivalent of a traffic jam that can't find an exit. And here's the kicker. Some of the worst debris clouds up there weren't accidents. They were deliberate. 2007 China tests an anti-satellite missile and shreds one of its own satellites on purpose. 2021 Russia does the same thing. Every one of those tests added thousands of pieces of permanent, decades-lasting shrapnel to a system already on a 5-day margin. It's like arguing for fire safety by setting off fireworks inside the building. So what are we doing about it? A lot, actually. The European Space Agency is developing something called omelette orbit maintenance via laser momentum transfer. Instead of sending expensive robots up to grab debris, omelette shines a ground-based, high-power laser at a piece of junk. The photons themselves push it. The laser heat vaporizes a tiny layer of the surface, creating a miniature thruster from the debris itself. That microscopic nudge is enough to change its orbit and prevent a collision. They've already tested the adaptive optics at facilities in the Canary Islands. The physics works. Now they just need the world to agree that a laser powerful enough to move a satellite isn't also a weapon. Meanwhile, Japan just pulled off something wild. Their ADRIS-J mission, built with the private company Astroscale, flew an inspection satellite to within 15 meters of a massive abandoned rocket stage tumbling in orbit. It studied it, mapped it, characterized its spin. This is the precursor technology to physically grabbing dead satellites out of space and dragging them down to burn up in the atmosphere. The tech works. It's here. It's now. By the way, if all of this sounds oddly familiar, it might be because a network TV drama just spent half a season on exactly this scenario. A billionaire ignores solar storm warnings. Satellites cascade. Debris rains down. Characters get stranded in orbit while first responders deal with flaming wreckage on the ground. When popular culture starts adapting your scientific warnings into primetime television, it usually means the public is catching on. The question is whether the policy catches up in time. Here's what this all adds up to for you specifically. If the crash clock runs out, if even one bad solar storm lines up with a controlled blackout, you lose GPS overnight. Global shipping stops. Aviation grounds. Precision agriculture fails. Banking networks that rely on satellite time signals start drifting. Weather forecasting, including the forecasts that warn of the next solar storm, goes dark. It's not the end of the world, but it is the end of the world as we have built it. And the people who can fix this have about 5.5 days to prove they can. If this video changed how you see the sky, do 3 things. Follow because I'm covering every space infrastructure story most channels won't touch. Comment the word orbit if you want the deep dive on Kessler Syndrome next. And share this with one person who thinks space is someone else's problem. 5.5 days. That's the number. Now you're one of the few people on Earth who actually understands what it means.